homework? I see no. Pretty easy. Number 32. I do not have the book in front of me, so will you give me that equation, please? So I need to do that exponent first. I need to FOIL, as y'all like to say, my x minus 1. And then I'll go through and take that 12 through to everything. So let me just focus on these two first. X squared minus x plus 1. Clean that up just a little bit. Combine your like terms. So negative x and negative x, is negative 2x. Now what? Distribute the 12. So I get 12x squared minus what? 24x plus 12 plus 4. That Aggie little 4 on the end. Combine him with the 12 now. And that would give me what, Miguel? 16. Does that answer your question? You literally said number 32. Do you really need it? Oh, thank you, Miguel. Are there any others that you have questions about that you would like me to work? I fell for it once, Dozier. All right, let's talk about factoring. Ready? Ready or not? Woo! Thank you, Emma. Woo! The perfect way to do it. Everything cannot be factored, so unfortunately it won't always work, but I will teach you something you can do when factoring won't work, but not today. Today we stick with factoring. No. All right. Before I teach you how to factor, let me teach you, or refresh you, I should say, about a GCF. Look at you go, Sully. You're on it. Greatest common factor. Which is your most basic form of factoring, really? What is a greatest common factor? Define it. What does it mean? What does it mean to be a greatest common factor? Give it to me in dummy terms.
The factor that both numbers share.
What's a factor?
The biggest number that both of them share. The biggest number that both of them multiply. The biggest number you can multiply. The biggest number that you can multiply that should.
I don't know how to word it. Like the biggest number that can be fitted.
The biggest number.
You gotta just shout it out.
The biggest number that can be multiplied by both.
The biggest divider. Factor means divided evenly with no remainder, right? That's what it means to be a factor. So we should first define that. It means it goes into the number evenly, or it goes into whatever it is you're looking at evenly with no remainder. Your remainder is 0. So the greatest common factor is the biggest thing that you can divide a term by with no remainder. So let's start easy. Let's do a couple examples and see. You look a little confused. Are you good? Are you just called? What is the GCF? The biggest thing that you can divide both 15 and 25 by with absolutely no remainder, in this case. Okay, then let me make it a little bit harder. Three x, right? I can take a 3x out of both of those. I can divide them both by 3x and have no remainder. So y'all have done this. What if oh, I didn't mean to put 7.
No, it's 4. It is 4. It is 4.
It's 2. Even though the first 2 have X's on them, the last one doesn't, so X is not part of my GCF. Okay? So let's talk about factoring these GCFs out of something. Y'all got that? I told you I'm going all the way back. This is going to be the first step we always do when we factor, is we factor out a GCF. So what do I mean by factoring out a GCF? So if I had, what was that problem we just did that Dozier made me work that he didn't really need? 12 times, once we got down to that one step, there was a 12 outside and inside was, no. Okay. Let's just say that's it. Doesn't really matter. Okay. What we've been doing is we've been distributing that 12 through, right? Say right, because that's right. This is what we've been doing. We've said that this equals 12x squared minus 24x plus 12. Well, what we're going to do now is we're going to take this and we're going to factor the GCF out of everything. So instead of distribute, it's the backwards distributing. That's all we're doing is backwards distributing. So instead of multiplying everything, we're going to divide everything by something. We're going to take it out and stick it on the outside. Okay? So my first question to you is, what's the GCF of that expression? 3x. 3x, right? If I asked you to factor that GCF out, I'm in the blue now, or the purple, whatever. 3, 15, and 27. So I'm going to take the GCF. It goes on the outside, so 3x. And now instead of multiplying, I'm dividing each one and putting what's left. So what's left inside my parentheses now? Is everybody okay? That is literally your most basic form of factoring. It's taking a common factor, or the greatest common factor, putting it on the outside and dividing out. Is everybody good with that? Oh yeah, that's just the preliminary. It's not going to be bad though. Okay, so the method, I needed to show you that so that as I run through these steps, if you can GCF, you can factor in the method that I'm going to show you. So if I give you any 2 terms whatsoever and you can find the GCF of them, factoring should be a pretty a cinch for you. It should be pretty easy. So what we're going to do is we're going to take these polynomials. I shouldn't say. We're going to take these quadratics, okay? And we're going to take them right now. We go from intercept form, right? Come on. To standard form. But what we're going to do when we factor is we're going to undo it and get it in an intercept form. Okay, so that's going to be our goal. Nothing to it but to do it. Yeah, sorry. This is multiply, or distribute, or FOIL, but backwards is the factor. What method did y'all learn to factor? Does anybody remember what I'm just curious what they're teaching at the middle school, how they teach you that.
Like in the two factors of P that add up to P. Two factors of P.
You're close, you're actually really close. Some people come in and they have all these little butterfly methods and box methods and all these other different little methods that they use sometimes to factor. It works sometimes and don't work sometimes. All right, I'm going to show you the method that always works. It's also the one that makes the most logical sense to me, which is why I like it so much. This is factor by grouping, and it will factor any quadratic for you that is factorable. Okay. So my very first step, and what I'm going to do is I'm going to run an example alongside here. The first time you see this, your head might spin a little bit, but I promise the more we work and the more we do, it will become second nature. This is the one lesson that I always tell everybody, when you get out of Algebra 2, you should be able to do left, right, up, down in your sleep. Any quadratic I give you, you should be able to factor. Do not leave Algebra 2 not knowing how to factor. Well, you probably won't make it out of Algebra 2 if you can't factor, because it's that important. So let's say I have 12x squared plus 14x plus 4. My very first step is to check for a GCF. No matter what else you do, you always want to check for a GCF first, and if it has one, you want to take it out. It's going to make your life easier in the end. So as I look at my example, 12x squared plus 14x plus 4, does that have a GCF? It has a GCF of 2. So if I take that out and put it on the outside, what does it look like? That is exactly right. Does that confuse anybody? Take out the GCF. First step always. Everything will not have a GCF, okay? But if it does, take it out. All right, here's where we get into, I always tell everybody this is a puzzle. Look at it like a puzzle. Sometimes the puzzle can be a bit challenging, but it's a puzzle nonetheless. And once you get the pieces together, it makes it so easy. Looking just at what's in parentheses, okay? You are going to multiply your ax squared times your c. What is ax squared times c? 12x squared. Here's the puzzle. You're going to find two factors that multiply to that ax squared times c, but they have to add to your bx, your middle term. Okay, I'm going to give you a second to copy that, and then we're actually going to do it. Have to watch your signs, because sometimes there's positives and negatives mixed all in there. We have to take that into account. But for right now, everything's positive, so we're good. All right. Two factors that multiply to 12x squared, but when you add them together, you get 7x. What'd you say? 4 and 3. 4x and 3x, right? Does everybody agree? Okay, what's 4x times 3x? Times 12x squared. You can add them together because they're like terms. What's 4x plus 3x? So if you get confused on which ones to use, here's what I would start doing. I'd start listing out every possible factor of 12 here. I could multiply x and 12x together. I could multiply 6x and 2x, 4x or 3. And then I go through, well, if I were to come in here now and put a plus in the middle of every one of these, which one would lead me back to? Okay. Once you have determined what those two factors are, okay, I'm going to rewrite my quadratic. Have y'all seen this method before? Okay. I hear yes, I hear no. Do you agree that 4x plus 3x is the same thing as 7x? Okay, then I'm just going to write it that way. So my next step is to rewrite the x. So now, instead of 7x, I'm going to write it plus 4x plus 3x. That plus 2 is still there. Do we all agree? I haven't changed the value of anything. Remember, we are literally doing the backwards of FOILing. If you think about what FOILing looks like, right? When you multiply it out, you do first, outside, inner, last, right? You end up with something that looks like this, and then you combine like terms, right? All we did was we just uncombined the like terms. We found the two like terms that would uncombine correctly. Not yet. I got to turn it into, right, intercept form is what it's going to look like at the end. That's the hardest part. It's downhill from here, I promise. This too just keeps following the problem. Okay, these are McGee notes that wouldn't make sense to a lot of people that aren't in here, but my next step is to slash the problem. What do I mean by slash? I mean literally go to the middle of these four and cut it in half, because we're going to look at this as two separate problems. Okay? And what we're going to do after we slash is we're going to GCF the first half and the second half. GCF it, okay? Are y'all ready? You good, Sarah? Okay. That 2 just keeps tracking right down with the problem. Ignore it, okay? That's going to be my A out front. Remember, all my forms have that A that sits out front? That 2 is just my A. Leave it alone. Pretend like it's not there right now, okay? If I look at this problem, what is the GCF of 6x squared and 4x? 2x. Are we all in agreement it's 2x? Take it out and tell me what's left. 2x, 3x, plus 2. Is anybody confused on that step? The GCF of 6x squared and 4x. Okay, yep. You following me? Okay. So that 2x here, the GCF of 6x squared and 4x is 2x. So I took that out. Okay. Your middle sign always stays. So drop that middle sign down. And now do the same thing for the second 2. But because one is always a factor of everything, right? So if you can't find a factor, 1 works. So the GCF here, well, but you need to write it whenever we're factoring. So here, the GCF is just 1. So I put a 1 outside, and I have 3x plus 2. What do you notice? They're the same. I have a factor that is the same. Now here's the part where you might need to go. You know how I've been factoring out a GCF? You know how if they share something, I take it out? Both of these now share a common factor. The common factor they share is just a big chunk. Okay? I'm going to take it out. So take out common factor. I'm going to put the common big factor. 3x plus 2 is shared by both of these. So I'm going to have 2 times, I'm going to take the 3x plus 2 out. If I take a 3x plus 2 away from both of these, what does it leave? 2x plus 1. And it's factored. I took out that entire 3x plus 2. If you have trouble seeing that, if this was 2x times y plus 1 times y, and I said, what's the GCF? What would you tell me the GCF is? Y, right? And if you take the y out, what does it look like? 2x. The only difference is my y is not y, my y is... Yes, absolutely. I told you, the first one you're going to go, what am I into? What happened to what? Okay, so it doesn't essentially disappear. What happens is you factor it out. If you were to FOIL this back out, it would come back out. But if you took, let's say you distributed that whole chunk. If I distribute it through, it would have to multiply to everything, and it would come. You would see it again. No. If you FOIL this back out, take just a minute, Sully, and do this. Everybody do this real quick, just so you see. FOIL this out because I want you to see that it's literally the backward step. Multiply 3x plus 2. Ignore the 2 first, and just multiply those 2 out. You can. What do you notice? Look at that in red. And look at that. Yes, absolutely. It's the backwards of the multiplying. That's what I'm doing. Now, if I combine like terms here, I'd be back up to here. Then if I distributed that 2 through, I'd be back up to what I started with. When you FOILed that out, right, you end up back here before you slashed it. Let's do another one. Okay. Factor it. We'll walk through this one, then I'll give you one to practice that we'll do together. We'll do this one together. Then I'll give you one to try on your own. Does it have a GCF? First step. No. 1, when we're looking for a general GCF on the outside, we don't have to put the 1 out there. That's only whenever we get into the factoring. But you're absolutely right, it's 1, right? Everything has 1. All right? So I can't really take anything out till I move on to the next step. Multiply the first and the last together. What do you get? 5x squared. So here's the puzzle part. I need 2 things that multiply to 5x squared, but they add to 6x. There you go. 1x and 5x. So now, instead of this being 6x, it's going to be 1x and 5x. X and 5x. Does that make sense? Okay. Let's try. We are going to slash and now we're going to GCF both halves. For the first half, what's the GCF? 1x, that's right. If I take out an x, what's left? Everybody okay? Middle sign stays. What is the GCF of the last two? Okay, so take it out. What's left? If you get to this point and your little parentheses are not exactly the same, you've done something wrong. Okay? Since they're the same, those are what I'm factoring out. See how these are the same? Is this the step you said you didn't quite understand? I'm going to take x plus 1 out. And what's left over? That's what's making up my last parentheses. Whatever's left over after I take them out. Well, I'm fixing to mix the signs up on you a little bit and show you how it can get a little, yeah. Okay. We found the GCF of both pieces. So we found the GCF of these two, and it was x. So we took it out of both. Then we found the GCF of these two and took it out of both. This one? Oh, these two values that we found over here, we took the middle one and we used, instead of 6x, we used 1x plus 5x, which is the same thing, but we just wrote it differently. Other questions? Ready for another one? No, we didn't. You can try it. Try it and see what happens. I will tell you this one's got a negative in it, so be very, very careful. And don't forget your first step. Always your first step. Boss, that's okay. It's a little different. Steps are still the same. I'm running through different scenarios with you that other teachers may teach you different methods. If you see this scenario, do this, but I want to show you that this method always works. I love the oh mamas. They're my favorite.
once you get here, I don't understand how you're doing the x plus 1 and the x plus 5.
Whatever that common factor is, still it's the same. If you take that out of both of them, well, one of y'all grab that, then I take it, oh, never mind. I write it in the front, thank you, Sully, and then whatever's left is what makes up the second.
So it's the common denominator between the two sets of parentheses.
And just make sure this plus sign stays here. But yes, since those are exactly the same, when they're exactly the same, you take them out and you put them in front.
And then x plus 5 is the other one. I didn't see.
No, in the very beginning. Oh. But you're really close. Don't sound dejected. It's okay. I'll find you. All right, step 1, GCF. Does it have one? It absolutely does. 2. If you take the 2 out of everything, what's left? That's all you got. Okay, next step. Multiply the first and the last together. Ooh, there you go. Good job. It's got to multiply to negative 6. It's got to multiply to positive 6, but add to negative 7. Well, two negatives multiply to a positive, but when I add them together, they're still negative, right? Negative 1 and negative 6. Does that make sense? See how this one's a little bit different? I got to watch those signs. All right. I'm going to rewrite negative 7x minus x minus 6. It doesn't matter which one comes first. And I'm ready to slash. I've got 2 times, what's the GCF of these two? X. If you take that out, what's left? That's right. Said it very quietly, but you are absolutely correct. The middle sign stays. The middle sign always stays. Okay? What is the GCF here? 6. Now here's where I'm going to tell you, be very, very careful. Because I'm really not taking the 6 out of these two, but a negative 6. Okay? So this might be where you need to put a little highlighted note in your notes. If the middle sign is negative, then the last sign changes. Remember, I'm backwards distributing, so I need to make sure that I'm taking the negative 6 out of both of those pieces. So what's left inside would be x minus 1. Remember, those two parentheses have to match when I factor. Okay, so that's the little hiccup if there's a minus sign there. Do you see the common factor now? What is it? X minus 1. If I take that out of both of them, what's left? Confusing? We're going to work several more, but I want you to take a break. I want you to look away from it for a minute. If you need to walk around the room, if you need to run to the bathroom. All right, factor it. Mark, set, go. Those are easy for you. Wait. It doesn't factor. Hold on. You've been using this. Okay, hold on, not that one. Yep, this is that book that I don't use because I don't like it, and this is exactly why. There's 5 times 2 is 10, so I've got 10x squared. There are not 2 numbers in this world that multiply to 10 but add to 10 also. Not in our real number system anyway. So this one, and listen, if y'all get on your homework and you turn, I'm not giving you any like this on your homework, so this one is cannot be factored. Do not get on your homework and write CBF, 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 CBF. I did my homework, okay? Because they can be factored. This just one cannot, and that's why. Yeah. Just that, but I want you to understand what that means, CBF. It means,
You're not allowed to write
it means what? Yeah, really, that's fine. Okay, here's one for you to try. I said that. I got you all excited. I'm trying, Doja, I keep trying to find just a plus one. We'll do this one, then we'll do the negative. Factor the polynomial. You can do that. I know you can. Oh, sorry. Factor the quadratic. We'll learn polynomials next chapter. Factor. Oh, yeah, it doesn't have an initial. It does, but it's not. No. The only time you have to bother with a GCF of 1 is whenever after you slash it. Anybody got it? Does this have an overall GCF? No. All right, so I move on to step 2. I need 2 things that multiply to 40x squared. Ooh, look at you. 8x and 5x. So I'm going to rewrite this 13. She didn't cheat. Sully doesn't cheat. Slash it. I know you don't. What's the GCF of x squared and 8x? 1x. Take it out. What's left? X plus 8. Middle sign stays because the middle sign always stays. GCF of 5x and 40. What's left? It better be what I had here if I've done things correctly, and it is. Now what's the yeah. That's fine. If you did them the other way, you'll still come out the same, and I'll show you what will happen in just a second. X plus 8 is my common factor. It leaves me with x plus 5. If you wrote those the other way, so if you wrote x squared plus 5x plus 8x, that is a-okay. That's another benefit of this method is it doesn't matter. When I slash here, the GCF is x. It leaves me with x plus 5. The GCF of the next ones, 8x and 40 would be 8, leaves me with x plus 5. The only difference is whenever I write it all factored out, my factors are flip-flop. But because multiplication is, what's the word that I can do it in any order that I want to, commutative, good job, then it doesn't matter which factor you write first. I'm impressed, Dozier. There you go. You're smart. I never doubted that. All right, let's do another. It what? Ooh, I'm going to do this. This is an all addition one, but we'll do it last. We'll do it next. We'll do it. Factor the polynomial. Oh, that's supposed to be a 12. Factor the quadratic. I'm sorry. I'm just kidding. Oh. What's GCF? 3. Leaves me with 6x squared plus 5x minus 4. First and last together gives me negative 24x squared. What are the two factors that multiplied in? Look at you go. 8x, negative 3x. Rewrite it. Does it matter which one comes first? No. I will tell you as you go through these, it's generally easier if you have a mixed sign like that. If you put the negative first, it'll make your life easier in factoring. But you can do it either way. What's the GCF of the first two? 3x. What's left? First two. 2x minus 1. Y'all following me? You did it the other way. Okay, I'll do it the other way and show you. The middle sign stays. GCF here would be what? 4. It leaves me with 2x minus 1. So I have 2x minus 1, 3x plus 4. If you swap that around. So if you had 6x squared plus 8x minus 3x minus 4, the GCF here, 2x, it leaves me with what? 3x plus 4. The middle sign has to stay. And remember, if the middle sign is minus, it causes that last sign to change. So that's why I said it might be easier to write your negative one first, but it's not wrong either way. What's the GCF here? 1, and that middle sign changes. So I end up with 3x plus 4, 2x minus 1, and then don't forget that 3 that we took out in the very beginning. How are y'all feeling?
Great.
Do we need to do some more, or are y'all okay? No? I hear no. We're good. Everybody's good. Speak now, forever hold your peace. Okay, let me tell you what